So, how big is the universe? You'd think that's a simple question, right? But the answer, well, the answer is going to stretch your idea of what reality even is. What if everything we can see is just the very beginning?
So let's ask it again. How big is it really? He's probably heard a number thrown around, some nice, neat answer that seems to wrap it all up. But what if I told you that number, as gigantic as it sounds, is just the first stop on a journey to a truth that is so much bigger?
93 billion light years. That's the one. That's the number you always hear. And hey, it is the correct answer, but only for the part of the universe we can see. And that one little word, observable, is probably the most important word in this entire conversation, because it's hiding a mind-bending secret. Because that is so not the whole story. I mean, not even close. So what's actually out there, beyond our cosmic horizon? Is there an edge? Just nothingness? Well, the real answer is way stranger and frankly, way cooler than either of those.
Okay, so to really get our heads around the kind of scale we're talking about, let's start from a place we all know. Let's start from home and just zoom out. We're going to build our way up from our little cosmic neighborhood to the biggest things we know exist.
All right, let's take a quick road trip. That jump from the Earth to the Sun, 93 million miles, feels like a lot. But you know, to even get outside our own solar system, to escape its gravity, you'd have to travel for 2 years at the speed of light. Want to cross our own galaxy, the Milky Way? Settle in. That's a 100,000-year trip. And our entire galaxy, our home, is just a single speck of dust among 100,000 other galaxies in our local supercluster, Laniakea. You see how every step just makes the last one feel impossibly small?
This next one is my absolute favorite way to picture this. Seriously, try to imagine every single beach on Earth. All of them. Now, picture every single grain of sand on all of those beaches. It's an impossible number, right? Well, for every one of those tiny grains of sand, there is a star out there in the universe we can see. The scale we're dealing with is just, it's staggering.
So, okay, we've established that the observable universe is ridiculously, mind-numbingly huge. But there's a major paradox, a real head-scratcher hiding inside that 93 billion light-year number. It just doesn't seem to add up.
Okay, so check this out. Here's the puzzle. We know the universe is 13.8 billion years old. So how on Earth can it be 93 billion light years across, right? Shouldn't the light from the farthest things we can see have only had 13.8 billion years to get to us? How does that even work?
The answer, and this is where things get a little weird, is something called cosmic expansion. The best way to think about it is to imagine you have a balloon with 2 dots drawn on it. Now, as you blow up the balloon, the dots get farther apart, right? Not because they're crawling across the balloon's surface, but because the rubber between them is stretching. That's our universe. The light from a super distant galaxy is traveling through space to get to us, but at the same time, the very fabric of space itself is stretching out. So in the 13.8 billion years that light has been on its journey, its home galaxy has been carried much farther away.
All right, so we've got a handle on the size of the part we can see. But now we get to the really wild part. Because cosmologists are pretty much certain that our entire observable universe, the whole 93 billion light-year shebang, is just an insignificant speck in a cosmos that is vastly larger. And that, of course, brings up the million-dollar question, right? If it's literally impossible for us to see past this horizon, how in the world could we possibly know what's out there? Well, this is where the real cosmic detective work starts.
It turns out there are 3 main clues, 3 separate pieces of cosmic evidence that all point to the exact same unbelievable conclusion. And they have to do with the leftover heat from the Big Bang, what happened in the first split second of creation, and the actual fundamental shape of space itself. First up, let's just look at the sky. If your eyes could see microwaves, you would see this faint glow everywhere. It's called the cosmic microwave background, and it's basically the afterglow from the Big Bang. Now here's the crazy part. The temperature of that glow is almost perfectly the same in every single direction we look. How is that possible? It would be like dipping a thimble into the Pacific Ocean, checking the water, and then declaring that the thimble is the entire ocean because the temperature is so uniform. The much more logical explanation is that our thimble, our entire observable universe, is just one tiny, smooth patch of something unimaginably larger.
Then we have clue number 2, and it comes from a theory called inflation. The idea is that in the very first trillionth of a second after the Big Bang, the universe expanded faster than the speed of light. It's an insane idea, but it explains so much. And one of the things it predicts is that this process is eternal. It's still happening out there, constantly spinning off new bubble universes. Our entire cosmos, everything we know and can see, would just be one bubble in a vast, endless cosmic foam.
And for our third and final clue, it's the actual shape of space. Every measurement we've ever taken suggests that, on the grandest scales, our universe is flat. That means if you draw two parallel lines, they'll stay parallel forever. Now think about this. The ground right under your feet seems flat, doesn't it? But we know it's only because you're on a very, very big sphere called Earth. For our universe to look so perfectly flat to us, it has to be one of two things. Either it's incomprehensibly enormous, or, and this is the simplest explanation, it's truly infinite.
So, you take all three of those clues and what are we left with? Well, two possibilities. And honestly, both of them are just as mind-blowing. Is the universe just unimaginably huge, or is it literally, actually infinite?
Let's just take the most conservative, most careful scientific estimate out there. Data from the Planck satellite suggests that if the universe is an infinite, then the whole thing must be at least 250 times bigger than the part we can see. And let me be clear, that is the absolute rock-bottom minimum. Most theories point to a number that's way, way bigger.
In fact, some of these theories of inflation predict a universe so big that the numbers we use to describe it, numbers like 10 to the power of 10 to the power of 100, they stop being numbers, you know? They're just symbols on a page. They have absolutely no intuitive meaning. Our brains just can't hold a number that big.
So, what does all of this actually mean for us, right? Here on our tiny blue dot. What's the takeaway? Let's try to bring this all back home.
And this is maybe the most important thing to understand. That edge of our universe, it isn't a real wall. It's just our horizon. It's a sphere centered perfectly on us. If there's an alien civilization in a galaxy way out there, they have their own observable universe, centered on them. And from where they're standing, we might be on the other side of their horizon. All that space out there is just as real as ours, but because the universe is expanding so fast, the light from those places will never, ever get to us. We are cut off forever.
I think it all boils down to this one simple and pretty humbling truth. We're trying to measure something that might, in the end, actually defy measurement itself.
So I'm going to leave you with this to chew on. We've gone from our own planet to the edge of everything we could possibly see, only to realize that the real universe is probably vastly, maybe infinitely bigger still. So what does that mean? What does it mean to be a tiny, finite little part of something so unbelievably grand? Is a question that really puts it all in perspective, doesn't it? Thanks for coming on this trip with me.